We're solving problem 23 from the spring 2021 AMC12 beat. 3 balls are randomly and independently tossed into bins numbered with the positive integers, so that for each ball, the probability that it is tossed into bin I is 2 to the power of negative bin I, for I is 1, 2, 3, ... More than one ball is allowed in each bin. The probability that the balls end up evenly spaced into distinct bins is P over Q, where P and Q are relatively prime positive integers. What is P plus Q? So let's just find the probability of it being into, well, we want it evenly spaced in distinct bins, right? So if it's evenly spaced, then that means there has to be a total difference. So let's just let the 3 bins be like so. Our first bin we want is x minus d, the difference, and then x minus d plus d, which is simply x, and then x plus the difference. We want to find the probability of this happening. Now, for 3 balls to be tossed into these bins, well, how many ways can that happen? That can happen 3 factorial times. And then you multiply that by the probability of each one happening. So in this case, it'd be 2 times to the power of negative probability of box A times 2 negative B to negative C. These variables are not like, well, they just represent the probability of the boxes. We'll get rid of them later. This is comes out to 6 times 2 to the power of negative A plus B plus C. In this case, we link A, B, and C to one of these unique factors, but it doesn't matter which ones we choose since we're finding the sum of all 3. So the sum of all 3, x minus d plus x plus x plus d, is just 3x. So therefore, this equation would be 6 times 2 to the power of negative 3x. You could have just wrote it all out with the powers of x's, but that seems to be a little disorienting. So then this we can simplify to 6 times, well, since it's negative 3 power of 2, it's just, we can simplify to 1/8 to the power of x. Since for this problem, we know that all the integers x have to be greater than or equal to 2, because the smallest integer of x possible is 2. So then we have this number, and then this equation will become 6 times x minus 1/8 to the power of x. Great. Now we want to find all the sums of these to infinity. So our equation then becomes bounds are x equals 2 to infinity times 6 times x minus 1/8 to the power of x. We can simplify this, put the 6 over there. 6 times the sum of x is 2 to infinity of x minus 1/8 to the power of x. Well, then we see here that this can just be a 1. So this can then just be condensed to, 6 times the sum of x is 2 infinity x over 8x plus 1. So this plus 1 is basically multiplying by another 1/8. So we can move that 1/8 over here. So this becomes 6/8 of the sum of all values x is 2 to infinity of x over 8 to the power of x. Now, for this specific case, if we have a case where we're summing all integers from x is 1 to infinity. This is not the same x, note it. And we have variables x over r to the power of x. This sum would simply be r over r minus 1 squared for a basic example. So now, if we use this on that, this then becomes 6/8 times, well, r over r minus 1 squared in this case would just be 8 over 8 minus 1 squared. These 8's cancel out, and then 8 minus 1 is 7. 7 squared is 49. Our total fraction is 6 over 49. So our sum, 6 plus 49, is 55, or our answer for this problem.